Most ESP32 projects start like this. A bunch of wires, a bunch of modules, and as soon as some sensors and digital outputs come together, it just becomes a total mess. You can't really figure out if you accidentally unplugged a wire or if you made some kind of routing error. But this is different. This is an ESP32S3 industrial controller from Waveshare built into a DIN rail style enclosure with proper screw terminals, Ethernet, PoE, digital inputs, digital outputs, RS485, CAN bus, Wi-Fi, Bluetooth, and actual isolation between the controller and the outside world. Instead of using another ESP32 dev kit with a breadboard, a bunch of wires and unsure connections, I would probably choose to go this route. Just a quick transparency before we start. Waveshare sent me this controller over. They did not declare any script or they did not told me what to say and what not to say, so I'm completely free in my opinion. But however, they sponsored this product. There also will be an affiliate link in the video description. If you want to check out the board, you can use that link and support this channel at the same time, which would be really nice. So thanks again a lot to Waveshare. The exact board is the Waveshare ESP32S3 PoE ETH8DI8DO. The name is not exactly short, but it describes pretty well what this thing is. At the core, it is based on an ESP32S3, so you still get the familiar ESP32 ecosystem, Wi-Fi, Bluetooth, Arduino support and all flexibility you would expect from a microcontroller board. But the important part is the industrial I/O around it. You get 8 digital inputs and 8 digital outputs. That means you can connect things like buttons, limit switches, door contact, sensors, relays, signal lights or other control signals without immediately building a giant mess of breaker boards and jumper wires. The board also has Ethernet with PoE, which is one of the most interesting features for me. Power over Ethernet means that depending on your setup you can run power and network for a single cable. For something mounted in a workshop, a test stand, a small machine or a control box, that is way cleaner than relying on Wi-Fi and a separate USB power supply. It also has RS485 and CAN, which makes it much more interesting for industrial sensors, Modbus modules, motor controllers or other distributed control systems. And the big difference compared to a bare ESP32 dev board is protection and isolation. The inputs and outputs are optically isolated and the board is clearly designed for more serious wiring than a normal breadboard prototype. This is not supposed to replace a certified safety PLC. I would not use it as the only safety device for something dangerous, but for automation, monitoring, test stands, workshop control, robotics supports, systems or home lab style industrial projects, this is a very interesting form factor. To keep this build realistic, I am not going to build a full control cabinet though. Instead, I'm building a small PLC-style demonstration. The goal is simple: 3 inputs, 3 outputs, a basic state machine and a small web interface. Enough to show you what the board can do, and that without turning this video into a massive 3-day wiring project for me. After the upload, the system powers up and starts in ready mode. When I press the start button, the controller switches into running mode. The yellow output turns on and you can see the change in the browser. Pressing stop now brings it back into running mode, and now the important part, the fault input. If the fault switch is triggered, the controller disables the normal outputs and switches on the red fault indicator. This is obviously a rather simple demonstration, but the basic structure is the same even for larger projects. You first read the inputs, then apply your logic, then switch your outputs and report your state back over the network. After testing it like this, I think that the biggest strength of this board is not its processing speed, or that it's the fastest ESP32 board or whatsoever. The strength of this ESP32 is a much more serious environment. You can get proper terminals, an enclosure, Ethernet, power over Ethernet, isolated inputs, RS485, CAN and a form factor that actually makes sense outside of a breadboard. For my own projects, I could see this thing being useful for a robotic arm test stand, a small automation box, workshop monitoring, sensor logging, machine status lights, limit switch handling or a small home assistant connected control system. This is not a certified safety controller. I would not use it alone for emergency safety stops on a dangerous machine. And the outputs also need to be wired correctly, especially when switching anything more serious than LEDs or small relays. Used in the right context though, it is a very clean way to build ESP32 based industrial styled projects. So therefore I think it's just great. Overall, I honestly really like the direction of this product. A normal ESP32 dev board is great for experiments, but it does not automatically make a clean controller. This board takes the ESP32 to a whole nother level and puts it into a format that makes much more sense for real wiring, real inputs and real projects. For me, this is probably not the final project that I will do with it, but it is definitely the platform that I will stick to in the future, because you also can just unplug all your wires and reuse it. Thanks again to Waveshare for sending me the board. The affiliate link is down in the description together with the product page and any code or project files I decide to publish for this very small little PLC automation demonstration. And if you are building ESP32 based control projects yourselves, this is definitely the kind of board that makes the whole setup look a lot like a final product and less like a temporary-ish prototype with a bunch of wires just dangling around.